In this video, we are going to understand ratios further, and the focus of this video is going to be a special case where we encounter the same ratio in different situations, and in those type of situations it is the interpretation of that ratio that becomes important. So let me try to explain this to you using examples. So we start saying that some ratios are very common in different situations. So let's take two examples. The first example is we have a length of a room which is 30 meters and the breadth of a room is 20 meters. It's a huge room. Now if we want to find out the ratio of the length to the breadth, that is 30 by 20, we get the ratio as 30 by 20. When we reduce it to a simplest form, we get 3 by 2, or the ratio is simply 3:2. Okay. That is the ratio that we get. Now consider another situation. Let us take example B, where we have 16 girls and 24 boys in a class. And now we want to find out the ratio of boys to the ratio of girls in that class. So the ratio of boys to the girls would be 24, which is the boys, and girls would be 16. Now when we reduce this to its simplest form by dividing it by 8, both the numerator and denominator, we get 3 by 2, or 3:2. So now when we observe this for both of these examples, we have the same ratio, which is 3:2. And other thing which you would see is that in the first example we started with a ratio of 30 by 20, which eventually simplified down to 3 by 2, or 3:2. Whereas in the second example we started with an initial ratio of 24 by 16, which initially reduced again down to 3:2. So this implies that we can have situations where the lowest form of a ratio can be same. It could be same as some other situation also. So these are known as equivalent ratios. So we can just say that 30 by 20, 30:20 and 24:16 in the lowest form are the same as 3:2. So these are the equivalent ratios having the same lowest form. So just to emphasize it again, equivalent ratios simply are those ratios which have same lowest form. So how do we get these equivalent ratios? So we can get equivalent ratio for a particular ratio by either multiplying or dividing both the numerator and the denominator by the same number. Please note that we have to divide both of them by the same number, both the numerator and denominator. So let us take an example and understand how do we arrive at the equivalent ratios. So we have here, find two equivalent ratios of 6:4. So we have a ratio of 6:4 and we have to find equivalent ratios. So the first one, see, now we will take both the methods. We told that we can either multiply or divide. Okay, so let's take first the multiplication method. So in this method we'll just multiply both the numerator and denominator, that is 6 by 4, by a same number. So if I multiply it by 1, I'm going to get it back, but I want a different ratio. So let us take 2, which is the simplest number. So what I'm doing multiplying the numerator and denominator by 2, and this gives me 6 times 2 is 12 and 4 times 2 is 8. So this is another ratio which I have got. And the second ratio we will find out using divide both the methods. Well, of course it depends on whether you can divide it or not. It depends on the number. So let's say that we have 6 by 4 in this case, and what I want to do is I want to come up with a I want to divide it with the number such that I end up with another ratio. So what we will do is, I can see that 6 and 4, both of them can be divided by 2. So what we do is we divide 6 by 2, and 4 is also divided by 2. So which gives us 6 by 2 gives me 3, and 4 by 2 gives me 2. So this is another ratio. So the two equivalent ratios that we found out for 6 by 4 is 12 by 8 and 3 by 2. Now you should use the division method only if you can see that you can reduce the numerator and denominator by some constant number. For example, in this case we could reduce the numerator and denominator by dividing both of them by 2. But if you were given 3 by 2, and then there is nothing more that you can do. If you divide them by 1, you will get the same number. So in that case, we will consider two separate multiplications. Right? We can multiply both the numerator and denominator by 2 and then by 3 to get the numbers. So now the equivalent ratios, they are represented as shown here. So we have 3 by 2 equals 6 by 4 equals 12 by 8. So this is the lowest form of the ratio, 3 by 2. This is the lowest form of the ratio, and these are other higher forms. So this is how we represent the equivalent ratios. In the next lecture, we will be working on several examples using ratios.